Okay, our second challenging example using right triangle trig. The bearings of 2 points on the shore from a boat are 115 degrees and 145 degrees. The 2 points are 800 feet apart. How far is the boat from the nearest point on the shore if the shore runs directly north-south? Okay, so we have the bearings of 2 points on the shore from a boat. So let's take our boat. We'll put our boat right here. And I'm going to make a north-south line so that we can more easily find our bearings. The bearing from the boat to the shore is 115 degrees. Okay, so 115 degrees, a little more than 90 degrees. Let's draw in our first 115 right here. 2 points on the shore. The second point on the shore is 145 degree bearing, so that's a little more. Let's draw in that 145 degree line, and we'll have, drawing in here, that's 145 degrees. Now it says that the shore runs directly north-south, so let's draw in that line for the shore as well. So the points on the shore, let's call them A and C. B is our boat. And it says that the 2 points are 800 feet apart, so let's fill that in. This is 800 feet here. Now, if you were to say how far is the boat from the shore, you wouldn't find one of these diagonal lines. We want to go directly to the shore, so we want to make a right angle to do that. So drawing in that right angle, the distance from the boat to the shore is what we're looking for. So if we're looking for x here, and this would make a right angle if we want the shortest distance to the shore. So let's fill in some of the angles inside of these triangles so that we can actually use them. Now for our smaller triangle here, the bearing was 115 degrees. 90 of it is outside of the triangle, so we're left with 25 degrees inside of the triangle. Second, we have 145 degree bearing. I'm going to use this large angle for our large triangle. 90 is outside. We've got 55 degrees in the triangle. Now, for the other sides, at point A, 25 degrees is the other angle in our triangle. So we're left with 65 degrees for point A. For point C, we have 55 degrees on the other side of the triangle, so we have 35 degrees at point C. Now, we have to label a little more on the outside of our triangle. We have 800 feet here. We don't have this distance, so let's label that as y, and we're looking, of course, for x. Okay, so you could use tangent or cotangent, it doesn't much matter, but since we don't want to deal with this distance or this distance, let's not use sine or cosine. We don't need the hypotenuse, so let's not use it. All right, so I'm going to use tangent. Tangent of 25 degrees is equal to y over x. We have opposite over adjacent. Tangent for our other triangle of 55 degrees is equal to y plus 800 over x. Now my goal is to solve for x. So I'm going to set each one of these equations equal to y to do that. So x tangent of 25 is equal to y. X tangent of 55 is equal to y plus 800. That means x tangent of 55 minus 800 is equal to y. Then I have equal to y and equal to y, so let's set these two equations equal to one another so that I can solve for x. I'm going to subtract to get the two terms with x in it on one side, so I've got x tangent of 25 minus x tangent of 55, and that's equal to negative 800. You could multiply across by -1 if you'd like to, but it's not necessary. Let's factor out the x. So x times the quantity, tangent of 25 minus tangent of 55, and that's equal to negative 800. Finally, x is equal to negative 800 over tangent of 25 minus tangent of 55, which means x is approximately, or the distance of the boat from the shore is approximately 831.7 feet.